we've discussed the tipping points on a few occasions, and you may have seen that I'm generally a bit circumspect. I don't know what the word is. They are real, and the risk is real, but they are not easy to predict by definition. Tipping points just happen, and there may be indicators. Let's say a volcano. You don't know exactly when it will go off, but maybe some tremors will begin to appear beforehand, or earthquakes may just happen without any warnings, and so on. And it's become very, you know, common now to discuss tipping points quite often. As we'll see, the terminology itself came from a popular science type writer, not really science. He does, we'll see. So what are climate tipping points? They sound scary, especially for ice sheets and oceans, but there is still room for optimism. I'm going to do this article again, which appeared in The Conversation, which is a very nice outlet, provide some fairly balanced views, often by people who wrote the paper in the first place and so on. But still, meltwater runs across the Greenland ice sheet in rivers. The ice sheet is already losing mass and could soon reach a tipping point. Basically, that means it's a point of no return. It's melting and it's accelerating, and suddenly it'll get so the melting rate will get so high that there is no return, that it will just keep going till the entire ice sheet disappears, let's say. Okay, and obviously Arctic sea ice is something that's been looked at as approaching a tipping point, and yet recently I just recorded a podcast saying that last couple of decades there has been no decreasing trend in September ice, and internal variability has been basically able to explain the variability. So we have to be always careful, and the main point I always try to make is that okay, there are actually potential tipping points in the system, and our models are not either good enough or they are not really capturing the kind of things we are observing, let's say like the rate of melting of these ice sheets in Greenland, or meridional overturning circulation, changes in the Amazon forest, and so on. And yet we have a tendency to keep pushing the narrative that the tipping points are getting closer, and they're closer than we think, and so on and so forth. So the uncertainty quantification becomes an issue, but the biggest point is then what can actually be done, right? Let's say a report just came out saying that the corals have reached the tipping point, and some of them may not recover at all. What is the uncertainty in these, and what can we do about them? People are trying to save some of them by watching how the ones that are responding well to warming, how are they doing this? They are associating themselves with symbionts that are high temperature adapted, and so on. So can we then begin to somehow do engineering solutions to save them? So it's a very complicated issue. So let's see what this particular article has to say. As the planet warms, it risks crossing catastrophic tipping points, thresholds where Earth systems such as ice sheets and rainforests change irreversibly over human lifetimes. This is critical that they happen within a lifetime, which is typically 25 years, but here let's say we give it a century. The scientists have long warned that if global temperatures warmed more than 1.5 degrees Celsius compared with before the Industrial Revolution and stayed high, they would increase the risk of passing the multiple tipping points in the system. For each of these elements, like the Amazon rainforest or the Greenland ice sheet, hotter temperatures lead to melting ice or drier forests that leave the system more vulnerable to further changes. And here 1.5 degrees C, we have already discussed elsewhere, is a number that is just made up. It's not really a scientific scientifically derived number, but nonetheless, if this is some kind of a threshold, we are going to look at and say what will happen to the system at 1.5 degrees C in terms of rainforests or ice sheets, then we still have to know what the uncertainties are and when we may hit this threshold and for how long we have to remain above this threshold for these impacts to manifest. Worse, these systems can interact. So freshwater melting from the Greenland ice sheet can weaken ocean currents in the North Atlantic, disrupting air and ocean temperature patterns and marine food chains through the Atlantic meridional overturning, global thermohaline circulation, and so on. So here, is typically what we look at in terms of tipping points. So we are looking at biospheric, cryospheric, and ocean and atmospheric circulation tipping points, potential tipping points, let's say. And the pink ones here are closest to tipping due to global warming. What does that mean? There is no exact number, closest as far as we can heuristically argue. So here we are, this is the meridional overturning, and you have Greenland ice sheet here, you have West Antarctic ice sheet down here, and you have the Arctic large permafrost and so on. There are kelp forests, there is the Amazon, Sahel, and the monsoon system, as well as we have tundras here, tropical rainforests, savannas and grasslands over here, and drylands, which is these yellowish colors all over here, and various other things like Atlantic meridional overturning, I mentioned, subtropical gyres, Southern Ocean overturning, West African monsoon, and cryosphere, of course, Greenland ice sheet, West Antarctic ice sheet, I'm repeating, but non-marine East Antarctica, marine basins East Antarctica, permafrost that I mentioned, and mountain glaciers. Okay, so these are potential tipping points, plenty of uncertainties, but with these warnings in mind, 194 countries a decade ago set 1.5 degrees C as a goal they would try not to cross. This is a bit inaccurate. The number 2 degrees C was adopted under Paris Agreement, and the Alliance of Small Islands and Developing States, AIDS, I think, they are the ones who said, let's bring it down to 1.5 C. So the Paris Agreement is actually 2 degrees C, but then you can do fancy footwork about it. But anyway, in 2024, the planet temporarily breached that threshold, and there is again disagreement. Not all data products agree on this. There are many, many details because these global mean temperatures we mention every year, they are not really just pure data. They are a blend of data and models, and sometimes we average pole to pole, sometimes 60 south, 60 north, all kinds of details. The term tipping point is often used to illustrate these problems, but apocalyptic messages can leave people feeling helpless, wondering if it's pointless to slam the brakes on our lifestyles. As a geochemist who has studied the ocean and climate for over a decade and recently spent a year on Capitol Hill working on bipartisan climate policy, I still see room for optimism. I typically don't show the author names in my podcast just to keep excitement of the authorship separate. So this is our author that's talking about himself. It helps to understand what a tipping point is and what is known about when each might be reached. That's where the rub is in terms of uncertainties. Tipping points are not precise. The tipping point is a metaphor for runaway changes. Small change can push a system out of balance. Once past the threshold, the changes reinforce themselves, amplifying until the system transforms into something new. So basically you went from one state to another, which is what the switch or the threshold or the tipping point is. Almost as soon as tipping points entered the climate science lexicon following Malcolm Gladwell's 2000 book, The Tipping Point, How Little Things Can Make a Big Difference, scientists warned the public not to confuse global warming policy benchmarks with precise thresholds. So we are asking people to worry about things despite all the uncertainties, which sometimes is necessary because if the risks are high enough, you still have to act. But the question is, what do you do? how do you make sure that you are actually making the right decision? Here is the Greenland ice sheet again, which is 1.9 miles, 3 kilometers thick as at its thickest point, and has been losing mass for several years as temperatures rise and make more of its ice drip into the ocean. A tipping point would mean runaway ice loss with potential to eventually raise sea level by 24 feet, so 7.4 meters, and shut down a crucial ocean circulation, which is the Atlantic meridional overturning that we mentioned here, which has lots of consequences for global energy balance and weather, climate, etc. So how close are we? 7.4 meters or 24 feet of sea level rise in the global mean is not trivial. Even though it gets distributed unevenly, it's going to make serious damage to many of the low-lying cities and countries, Bangladesh, New York, Miami, you can think of many, Mumbai, Chennai, etc. The scientific reality of tipping points is more complicated than crossing a temperature line, though. Instead, different elements in the climate system have risks of tipping that increase with each fraction of a degree of warming. And there are also papers now arguing that the tipping points interact with each other and can have positive feedback. So we are good at cranking up the handle even when there are uncertainties, which sometimes worries me as well. For example, the beginning of a slow collapse of the Greenland ice sheet, which could raise global sea level by about 24 feet, is one of the most likely tipping elements in a world more than 1.5 degrees C warmer than pre-industrial times. Some models place the critical threshold at 1.6 degrees C, but again, are the models really good enough to know the difference between 1.5 and 1.6, or whether nature itself cares about such a small difference in the global mean? Because 1.1 degree difference in the global mean is a lot of energy, by the way. More recent simulations estimate runaway conditions at 2.7 degrees C of warming. Both simulations consider when summer melt will outpace winter snow, but predicting the future is not an exact science. As Niels Bohr said, predicting the future is always predictions are always difficult, especially when it's about the future. So here is another IPCC infographic that we always look at. Gradients here show science-based estimates from the Global Tipping Points report of when some key global or regional climate tipping points are increasingly likely to be reached. So these are descriptors that are not very precise. Every fraction of a degree increases the likeliness reflected in the warming color. Global Tipping Points report came from, it's a European team dominated by the Europeans, US. Others actually don't pay much attention to this tipping point business, honestly. Okay, so coral reefs die off. We are here, the current level of warming, and Paris range is 2 degrees C, and here is 3 degrees C warming and 4 degrees C in excess. So you have West Antarctic ice sheet collapse, subpolar gyre overturning, mountain glaciers retreat, Atlantic meridional overturning circulation collapse, Amazon rainforest dieback. So you can see where the current level of warming is and where the colors are for some of them. And there are uncertainties in these. These lower if models are too stable, so it depends on the models as well, and not all models agree on all the things. Lower with additional deforestation in terms of the risk at which this will happen is lower than what we are looking at in the colors here. So this is increasing likelihood of crossing tipping points as temperature rises. So what do you do with this kind of incredibly schematic and very fuzzy kind of risk indicator? What actions can be taken? At the outset, mitigation, decarbonization, keeping the warming to as low a number as possible, phasing out coal and fossil fuels and moving to carbon-free system are all things that must happen, and they must happen urgently. Will these add any urgency to those, or will they just create people who will just deny more and more things. We have to worry about those as well. Forecasts like these are generated using powerful climate models that simulate how air, oceans, land, and ice interact. These virtual laboratories allow scientists to run experiments increasing the temperature bit by bit to see when each element might tip. Climate scientist Timothy Lenton, who leads this business, first identified climate tipping points in 2008. In 2022, he and his team revisited temperature collapse ranges, integrating over a decade of additional data and more sophisticated computer models. But the models have all kinds of uncertainties, and beyond a couple of decades, the uncertainties in the range of warming, etc., depend on the scenarios you assume for making these future simulations. So what do you do with that? Risks are there. Risks are there, and we know they are getting closer with warming, but just saying they are closer than we think, or they are getting closer, what exactly is supposed to happen? There are 9 core tipping elements include large-scale components of the Earth system's Earth's climate itself, such as ice sheets, rainforests, and ocean currents. They also simulated thresholds for smaller tipping elements that pack a large punch, including die-offs of coral reefs and widespread thawing of permafrost. So, as I said just a few weeks ago, the a report came out that claims that some coral reefs have already crossed the tipping point. The world may have already passed one tipping point according to the 2025 Global Tipping Points report. Coral reefs are dying as marine temperatures rise. Healthy reefs are essential fish nurseries. I have a hiccup. Fish nurseries and habitat, and also help protect coastlines from storm erosion. Once they die off, their structures begin to disintegrate, all well, but we also find some corals that are doing well, thriving even in a warming, and they are adapting in many sophisticated ways, which we don't understand or didn't guess, which means we don't always know how the system responds. We look at what's happening and try to extrapolate it, and saying they have passed the tipping point is a major extrapolation. Some tipping elements, such as the East Antarctic ice sheet, aren't in immediate danger. The ice sheet's stability is due to its massive size, nearly 6 times that of the Greenland ice sheet, making it much harder to push out of equilibrium. Model results vary, but they generally place its tipping threshold between 5 degrees and 10 degrees C of warming, so the uncertainty is quite massive. Okay. Other elements, however, are closer to the edge. Closer to the edge means what? This is what you have to imagine, that you are drifting in a boat and there is a steep cliff coming off, and if you don't get out, you are going to go off and then may die. But the question is, when do you jump off? If you jump off too soon, you may not be able to save yourself, but there may be a point closer to the cliff that may allow you to get off to the shore more easily. So there may be all kinds of options as to choose when you do what. So those are not easy decisions. Alarm bells sounding in forests and oceans. In the Amazon, self-perpetuating feedback loops threaten the stability of the Earth's largest rainforest, an ecosystem that influences global climate, no doubt. As temperatures rise, drought and wildfire activities increase, killing trees and releasing more carbon into the atmosphere, which in turn makes the forests hotter and drier still, and of course deforestation and soybean growth and development, all sorts of things are happening in the Amazon as well, despite these warnings. By 2050, scientists warn nearly half of the Amazon forest could face multiple stressors. That pressure may trigger a tipping point with mass tree die-offs. The once damp rainforest canopy could shift to a dry savanna for at least several centuries. So, 2050. How sure are we about this timeline? Who will make a decision that far into the future? If it's a global common and Brazil is the one who has to make the biggest decisions, how do we convince Brazil to make these tough decisions? How do we incentivize Brazil to make this decision, etc.? Rising temperatures also threaten biodiversity underwater. The second Global Tipping Points report, released on October 12, 2025. I'm recording this on October 27, 2025, and this was by a team of 160 scientists, including Lenton, suggesting tropical reefs may have passed a tipping point that will wipe out all but isolated patches. I myself am quite uncertain about this result, and most importantly, what can we do about it? If there is a way to actually come together and do something to improve their chances of survival and not hitting this tipping point of die off, then it'll be great. But among all the choices we have, what is going on right now with Ukraine, Russia conflict, energy markets, US having some political issues, Europe using US as an excuse to backtrack its own climate commitments, and the numerous other issues, coal still being the king in power generation, decarbonization, carbon capture not still scaled up, and so on. Where does this fit in terms of decisions? Corals rely on algae called zooxanthellae to thrive under heat stress. The algae leave their coral homes, draining reefs of nutrition and color. These mass bleaching events can kill corals, stripping the ecosystem of vital biodiversity that millions of people rely on for food and tourism. Low-latitude reefs have the highest risk of tipping, with the upper threshold at just 1.5 degrees C. Uncertainty there. The report found this 1.5 degrees C threshold. Above this amount of warming, there is a 99% chance that these coral reefs tip past their breaking point. Not all models will agree, and this derivation is got many arguments in them that you have to be careful on how you take it. Similar alarms are ringing for ocean currents, where freshwater ice melt is slowing down a major marine highway that circulates heat, known as the Atlantic Meridional Overturning, or AMOC. So here we are with the AMOC, how the Atlantic Ocean circulation would change as it slows. This is the IPCC 6th assessment report. So we'll come back and look at this. So today, here we are, AMOC, generally sinking water in the Jin Seas, Greenland, Iceland, Norwegian Seas, going south, and then warmer waters coming in to fill these things, warm surface current driven by winds and replenishing, sinking close to the poles. Water cools, becomes heavier, sinks to the bottom. In a warmer world, we would perturb these, so you can see the arrows get thinner, these get thinner, and some changes happen. Very schematic. Is this a real chance? Of course, if you put enough fresh water, we have evidence from the past climates that this can change quite seriously. Exactly when it will happen and what will exactly be the impacts. Kind of interesting to watch for. The AMOC carries warm water northward from the tropics in the North Atlantic. As sea ice forms, the surface gets colder and saltier, and this dense water sinks. The sinking action drives the return flow of the cold, salty water southward, completing the circulation loop. So I'm reading fast because I have recorded these in great detail elsewhere, but melting land ice from Greenland threatens the density-driven motor of this ocean conveyor belt by dilution. If you're evaporating and the water is very fresh, you won't get enough salt, so you won't form heavy water, so it won't sink, so you will change the whole circulation, so fresh water doesn't sink as easily. A weaker current could create a feedback loop, slowing the circulation further and leading to a shutdown within a century once it begins, according to one estimate. Like a domino, the climate changes that would accompany an AMOC collapse could worsen drought in the Amazon and accelerate ice loss in the Antarctic. So even if you assume 1 century is not such a long time for taking action, we are already having action to reach the goals of net zero by 2050, what should happen by 2030, and decarbonization, etc., etc. So how exactly are we going to worry about something 100 years away? You know, typically we say future generations will be better at taking care of themselves and the system, but these are not easy questions. Questions about the closeness of other tipping points. Not all scientists agree that an AMOC or rainforest collapse is close. I'm one of them. In the Amazon, researchers recognize the forest's change, but some have questioned whether some of the modeled vegetation data that underpins tipping point concerns is accurate. It's very suspect. In the North Atlantic, there are similar concerns about data showing a long-term trend. In fact, there are papers arguing based on observations that there is no observable trend in the AMOC at all. The Amazon forest has been losing tree cover to logging, farming, ranching, wildfires, and the changing climate. Pink shows areas with greater than 75% tree canopy loss from 2001 to 2024. Blue is tree cover gain from 2000 to 2020, so patches of that and so on. Other changes driven by rising global temperatures like melting permafrost could be reversed. Permafrost, for example, could freeze if temperatures drop again. So we have to still understand the natural variability and the slowdown in the sea ice loss in the Arctic, for example. Risks are too high to ignore, though. Despite the uncertainty, tipping points are too risky to ignore, which I would agree with, but then what do we do about it? Rising temperatures put people and economies around the world at a greater risk of dangerous conditions, but there is still room for preventive actions. Every fraction of a degree in warming that humans prevent reduces the risk of a runaway climate conditions. Reducing greenhouse gas emissions slows warming and tipping point risks. Tipping points highlight the stakes, but they also underscore the climate choices humanity can still make to stop the damage, and we are having plenty of trouble with those decisions already, despite the tremendously damaging years of 2023, 2024, and 2025. If such a hard-hitting extreme weather impact on economies doesn't stop us from, fighting various wars that seem so unnecessary, are we really going to worry about something that may happen 100 years into the future, and there are so many uncertainties about it anyway. So I'm going to leave it here. I keep on recording these because I really think it's an important issue, but there is one group which is pushing it very hard because they're convinced this is very critical, but it isn't clear to me how that's going to change the narrative on what needs to be done, for which we have plenty of reasons already in terms of the urgency of needed climate actions. Okay, let's leave it here.